should have been seeing the bell work. Did I not move the bell work? Shoot. All right, if I wasn't showing the, I mean, well, no, I showed the bell work and I said take a picture of it. Hopefully you got it. That may have been before I showed it. So yeah, the bell work's due at 12 for you guys online. All right, so we're recording. So again, she makes good money. She doesn't have to deal with people. She actually gets to work from home. She doesn't even have to go into an office. She works from home, which a lot of people that work with data do work from home, especially these days with the whole COVID stuff. So on this particular graph, we've got points, we've got coordinates, we've got, I hate when I call them dots even, but they're dots on the graph. These represent data. And this is why there's so many jobs that do this, because every company, there is no company that doesn't deal with data. Like that data drives everything a business does. Even if you go into business for yourself, data should be driving decisions that you make. Why would data drive decisions? Anybody tell me what you would use data for? Why would a company need data? What's important about data? I'm sorry, what was the answer? Well, I mean, that's not really data. Data has to do with numbers that were about the money you counted. So why? James, you had your hand up, and then Wonderson, I'll come.
Yeah, I forgot.
Okay. Okay, well then I'll come back to you if you remember. Wonderson, what's important about data? Why is data helpful? What's important about it?
You can report, like the money you're making, or.
So, kind of, again, about you can record, but why is it important to do that? What's why? I want the why.
Keep track.
But why is it so? I mean, that's still not the why. Why is it important to keep track? Why is it important to know how much money I make? What do you mean by? All right, so we'll probably come back to that when I'll relate with somebody else, because I'm sure somebody will say something related. What do you think, Valencia? All right, you can add on. Yeah, always adding on to anybody is extremely helpful.
I can't hear her.
I'll repeat it because I can hear it. Now, I will tell you right now, this is totally unrelated to what we're talking about. There are no companies that use data like insurance. I was in insurance. Everything in it, like when you have to buy insurance and pay for insurance and stuff, like it could be about, Aflac, like the accident, all that kind of stuff. Everything they do, the amount of money they give you, the amount of money they charge. So kind of answering the question now. Real quick before I answer. So I'm going to say that differently when I answer it. Right now, I'm about to answer it. Data, historical data. So whatever happens in the past is typically a pretty good predictor of what's going to happen in the future. That's why you use data. Like if we sold a certain amount last year, well, there's a good chance the amount we sell this year, unless something really dramatic changes, probably going to be fairly similar. So let me ask you as an example of that. How would Walmart maybe use data about their sales? What happens? Could be Walmart, could be Target, could be an online, could be an Amazon. What would happen that would be really important for them to know as an upcoming, let me give too much away, like something that's important for a retail business? How many things they sell, right? Historically, I want to know, but what's important? And what was the last one? So in a year, let's talk about 1 year. What happens in 1 year if you're a retail business? And you guys may not know this, but again, a lot of you will work in retail, so this is something good to know. And you might work in retail anyway. What happens within a year that is really important to know if you're a retail business? Retail means people are coming in and buying into your store and buying stuff. So like any shop in a mall, Walmart, Target, Amazon, even online people are online retailers.
What's your income and what's your
You want to know that, so that would be profit, revenue, and then expenses. But there is something within 1 year super important for them to focus on. Even if they're focusing on it at a different time, and they do, they get prepared way before this happens. I'll give you one more hint. It has to do with the time of year.
Oh, when there's, what you call it, when the season comes in.
What's the season? What's
Springtime sometime.
Well, Christmas, more specific. When Christmas is coming up, some retail businesses do half of their annual, like their whole year, whatever they're going to make in the year, they do half of it in just the 2 months right before Christmas. So like November, December. Probably more than that for some, in all honesty. Like you've heard of Black Friday, like it's technically not the biggest shopping day of the year. That's kind of a false concept that's been put out there forever. But it is a huge day. Everything from the end of November, so after Thanksgiving basically, all the way through December, they're gonna crush it. So if you don't make plans, like so let's say you never track data, and you didn't know how much more sales you were going to do. Well, what's tied into, so big deal, they're gonna sell more. Why is that important? Why do I need to plan for that's great. Why do I need to plan for that? That's great, I'm gonna sell more. I don't need to worry about it. It's great, just gonna sell more, right? Why is that important to plan for? What do you need to plan? And again, this would apply if you start your own little business, and again, some of you will do this. I guarantee you, it may not be your only business, but you'll do like maybe a little side business where you sell stuff and make some extra money. Hopefully, and by side business, I don't mean illegal side business, it's legitimate. I'm talking about selling them. What is important to plan for those companies? Why is it important to plan for that time of year? So what are you planning for? If you're going to be selling a lot more, what are you planning for? What was that? Oh, there's a great word. Quantity works. Inventory. You know what inventory means? It's what you have on hand to sell. Like if somebody comes in and wants to buy something, let's say you don't plan for it. You don't have any historical data. Let's say you sell, give me something that's like a common thing to sell. A thing, a physical thing, not a service. Phones, let's say cell phones. You're a store and you sell cell phones. You're a Sprint store. And I'll guarantee you their sales go through the roof at the holiday time. People, first of all, they give specials and stuff. And that's another thing, like they need to plan, are they going to do discounts? And I guarantee you their competitors are thinking about doing that, so they need to figure out, are they going to do it? How much? Let's say you don't keep historical data and you're selling like March, April, May, you're selling, I'm going to use a very low number, I'm sure it's way over this, you're selling 100 phones a month, March, April, May, 100. So at most times you got like 100 phones in your store or so. So that you can sell about 100 over that time period. Then all of a sudden Christmas comes in, you have 3 times as many people coming in, but what's going to be the problem? You don't have enough phones. Think of all the customers you just lost because you didn't prepare for it. What might you also not have enough of besides just the phones? Maybe money, but before the money part, who waits on the customers? Employees, right? If you got 3 times the number of people coming in, if you're again in a storefront where people are coming in, how long is somebody going to want to wait in your store before they get mad and frustrated and walk out and go somewhere else? I'd argue not a real long time. Not when there's all kind of Sprint stores and T-Mobile and this and that. So you have to plan for all kinds of things. Inventory and employees are 2 big things. So anyway, extremely important that businesses use data, historical data to predict future data. So that's all a graph really does. It helps you predict and make future decisions based on the past data. So the way you do that, oh, just the real quick answers on this. It is data. Scatter plot is specifically what we'll call it a lot of times. There is an X and a Y axis, so X and Y. Why aren't we showing the whole graph? Anybody have an answer for that? Why are we only showing this quadrant instead of the whole graph? Like every time we graph, we've been showing a whole graph. Why aren't we showing that here? Oh, why? Now, sometimes on a data chart, you will show the whole.
Because it's inclining.
Yeah, I could still show an incline going from down here up through there, though. I could have shown the negative part and had an incline going through the negative part. Let me ask you this question. What was the example I just used? What were we just talking about? Come on. Wake up. The faster this goes, the more time you have to work on the extra credit stuff. Well, the grade and the extra credit. Oh. We'll talk more about this in a second, but let's say that was the example. Let's say that's what we were just talking about. The bottom would be how many phones we sell. The Y would be how much money we get from selling those phones. Can we sell a negative number of phones? No. Can we receive a negative amount of money? And that's different than profit. Profit is, you could be negative in profit, but you can't receive a negative amount of money from customers. There are a lot of things, data-wise, there are no negative numbers that can happen, just like this. There are no negatives that can happen for the number of phones we sell. There's no negative amount of money customers can give us. So we just show the positive part of the axis, but there are still, I mean, it's still the same concept. It is still just like this, only we know we're only going to need the positive numbers, so we're just showing the positive one. That's the only difference. Same exact thing we've been doing as far as graphing. So what we would do, tell you what, I'm going to go ahead and skip the next one because we're doing the same thing. So we have now what's called a trend line. We talked about this before when we did this lesson. This is old, by the way. You actually did this in 8th grade, supposedly. It was the COVID thing, so maybe you did or maybe you didn't get it to. It's the last thing you do in 8th grade. I taught 8th grade 3 years ago. So this line is the best guess we have for the line that goes right through the middle of that data. That's what trend line means. Like you can read it. It says the line that models the data in a scatter plot, blah, blah. That just means draw a line straight through the middle of the data. And that line is our expected result. The line, again, I'm going to say it one more time. You may want to write this down. I didn't tell other classes to, but the line is the expected results. It's based on the data that we have. So the data is what drives us creating a line, or really more technically a computer will probably create it, because we can create it by, like I'll show you. So I can put points on here. So I can put points on here like this, and I could say, all right, let me draw a line through the middle of that data. And then I'm actually going to do something real quick and label them. Should put those numbers in first. All right, so let's say we've got that set of data. So again, I just drew another line that goes right through the middle to the best of my ability. It's not going to be perfect unless the computer does it. And I've got trend lines in both of them. What direction is that line going? Really? What direction is that line going? Both lines going.
Up.
Up, right? What did we say that was called, though, when we did? Does anybody remember?
Vertically.
No, vertical would be the y-axis. What's the slope of that line? Like, not the number, but it's the slope would be a positive. That's what I was going for. So we said if a line is sloping up, it's a positive association or a positive correlation because the slope would be a positive number. The line goes up from left to right, it is a positive slope, therefore it's a positive association. If the line were to go down from left to right, like that would have a line that goes down from left to right, that would be a negative correlation or a negative association. All right, so again, the line is our estimate of what's going to happen based on the data, which are the points. So the points are the past data, the line is what we would use to estimate. So here's what I want you to tell me. Oh, I don't want to do that. Let's get away the answer. If I think that I'm going to sell, oh shoot, what are the numbers standing for? 10, 20, 30, 40, 1, 2, 3, 4. Going by tens, but what do they stand for? 10 what? That's exactly what this stands for. This bottom, the x-axis, is the number of items sold. But let me, well, let's go ahead. What about the top, the vertical line? What would that maybe be? If one's the number of items sold, what would maybe the other one measure? What's that? Exactly. Fantastic. Look at you sleeping and still getting interest. This, and this is pretty common with graphs. The vertical, the Y, is a lot of times going to be the money, or we call it revenue. Really. Yeah, I guess. Because everything we do today is going to be important. Most of the next stuff is going to be important for you specifically when you get back. And again, I'm not going to rewrite number of items and revenue, but it's the same thing on the other graph. Graph is the same exact way. I'll write that part and then down here. But let me ask you this. Again, let's say this is a big company, or even doesn't have to be a huge company. Are you telling me I'm only going to sell 10 things and make $1? That doesn't make sense. What's wrong with my graph, or what do I need to understand about my graph? Trying to figure out how long I'm going to wait for answers. I think I'm just going to go forward. When you get graphs, they're typically not going to be in the way we've been doing graphing, where it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, negative 1, negative 2, negative. It's not going to normally be like that on data charts, because data is not going to be just in the 1s and 2s and 3s. It's going to be in the thousands. So normally what it would say is something like this, like in parentheses. It would say N000 and then a little S. That means those are measured in thousands. So 10,000, 20,000, 30,000, 40,000. Then over here under revenue, oh, I should have written it down here. And then under revenue, it might say N, and they would put numbers there, or maybe letters. They might say NMs, which would mean in millions. So here's what you need to be able to do, and this is something I might quiz you on, but you'll definitely see it next year on the end of course exam. They might give you graphs like that, either 1 or 2, and they might say, if you sell 25,000 units, 25,000 items, what is your expected revenue? What is it? Who thinks they can answer that question? Just wait. If you sell 25,000 items, what's your expected revenue? Again, the line, remember the line is our expectation. That's what we expect to happen. Well, if there's one, I'm telling you at one number, 25,000. At 25,000 units, that's how much we're kind of saying, well, let's base our number of employees, for example, or maybe our inventory. Let's base that on selling 25,000. how much money would we be making, or not technically, not profit, but how much money would we bring in from selling 25,000 phones? How much? Well, we're probably going to make more than 25,000. Phone doesn't cost $1. And I'm not even, this doesn't really even have anything to do with the price of phone, but I take that into consideration when I'm creating. You need to know how to read a graph on that. So again, everybody head up real quick, because you do need to know this part. Valencia, Wanderson, Cortez, Christine, Michael, good Lord, everybody. Yeah. Oh, you're flipping. Wake up. Valencia, wake up. Wake up and wake up. Wake up. Oh my God, they were out like a light. I thought their heads were just down. They truly were out, I know. I thought you guys just had your heads down and weren't listening. You were truly out. All right, so you need to know that if so this is my number of items on the bottom, right? My estimate, I would just go to where 25,000 is. So again, if this is my number of items on the bottom, this is 10,000, 20,000, 30,000, 40,000. Well, 25,000 is right here for both graphs. That's where 25,000 is, right in the middle of 23rd. Then I just need to, and the line is my estimate, like that's what's telling me my estimated revenue based on the number of items. So I'd come up to the line. I'd say, all right, well, right here is where I hit the line. If I come over, that's pretty much right between the 2 and the 3. So that's a $2.5 million revenue estimate at 25,000 units. Down here, it's pretty close to the same, but the way the data is down here, again, we go from 25,000 up the line. Might be a little bit higher, so let's say that's 2.6 million. So that's how you read a graph. You need, I mean, that's like guaranteed stuff that will be on your scatter plot section of your EOC next year. It's not hard. You need to know how to read a graph. Here's my next question though. So let's say this was company A and this was company B. Which company would you rather be? Raise your hand if you would rather be company A. You made 2.5 million. You'd rather be A. You only made 2.5 million. Why? Well, raise your hand if you'd rather be company B that made 2.6 million. All right. So I have 3 people participating. So at first glance, you might think, yeah, I would rather make more money, right? Doesn't that make sense? I'm estimating, the line is my estimate for how much I'm going to make. I would rather the estimate to make more money. Here's the problem with the data, though. This is one of the things you need to understand, and one of the things I could ask a question on. This is an estimate. This line is just an estimate. There's no guarantee we're going to hit our estimated number. Our estimate might be off a little bit. Maybe we didn't take something into account. So now our historical data is still pretty good. So we still want to take that into account. But let's say we have a bad year, not as good as we thought. And up here, you see all the dots are pretty close to the line. So if we miss our estimate, we're still probably going to be pretty close to the line. So if we do that, that would be about 2.5 million. I'm sorry, about 2.2 million. Like it's just barely above 2, right? So maybe about 2.2 million. Down here, though, I'm going to put a different color since I have so many red dots on here. If we miss our estimate down here, we might be way down here. Like if we have a bad year, we might be way below our estimate down there. That's not good. That's not good at all, because this might be 1.6. I'll tell you right now, you're a business, you cannot afford to miss a projection by that much. I mean, even if it's smaller numbers, you're still like barely over half of what you were estimating you would make. And again, these companies are making decisions way ahead of time, and if they're spending money, they're spending it way ahead of time. You just will not stay in business. So here's the kind of the end of this. You would rather be this company that has the better data, like the data that's more reliable is what we would call that. This data is much more reliable than this data because it's all a lot closer to the line. So here's, now go to your sheet 3-6. So all of you that are awake, this will pay off for you later. Because this is one of those kind of questions on a quiz where if you've got it in your notes, all you got to do is pull your notes out and copy it down. So look at the first of all, write everything up that I wrote. Draw the pictures, write everything I have in blue, except you don't have to write this one little line. Now write everything I have in blue. So, well, I'll probably not. Yep. Did you write all that down? Let me finish this because you need to understand what they are. So this will be one of those questions where I'll say that should be right in your notes. And if you don't have the notes, then it's not going to help. Michael, you got all this? Wanderson, Valencia. I'm giving you potential test. Well, not even potential. I mean, it'll be on a test somewhere, and all you got to do is have it in your notes. Not to mention, this is the last thing I remember before I do grades for all of them. Well, this and what you're going to do right after. All right, so I think you should be done. The first thing you need to know is this word, or these two words, correlation coefficient. Oh no, we can do that. There, correlation coefficient, if you weren't able to see it. Were you able to? Oh, it's on your paper. That letter R is just a variable we use for that particular thing, that correlation coefficient. Just like for slope, we use M. For y-intercept, we use B. For correlation coefficient, we use R. It's just the letter they use. Don't know why, it's the way it is. Has nothing to do with the letters in the words. So what this word means, oh, and it's always between -1, so it's always greater than or equal to -1, but less than or equal to 1. So it's always a decimal, or it's -1 or 1 or 0. So what the two parts of this mean, the negative sign, so here we have a negative sign, right? So I'm dealing with all the numbers that are on the negative side of 0. That just means there's a negative association. The data would be slanted down. So the negative tells you the data slants down, or that the line would have a negative slope. Again, here we have a positive number, so that tells you that the data slopes up. The number part, just the digits, just the number part, that tells you how close together the dots are. So the higher the number is, the closer together the dots are. So you see here we have a 0.976, and the dots are closer together than over here we have a 0.875. So again, the correlation coefficient, you always want that number part to be higher because you want to know that your data is more reliable. The closer it is to the line that you would draw, the more reliable the data is. Here, this data is completely unreliable. There's no, I mean, I don't see any pattern at all. Like, it's almost exactly on 0, and exactly 0 would mean there is 0 pattern. There's no relationship at all between X and Y. So the data just would look completely scattered around if you ever had a number like that. It doesn't mean just because it's positive doesn't mean it's a positive association, because there's not an association. There's no association for this. Remember, and you may not remember from the last lesson, but if the data is scattered around like that, that's no correlation, no association. So if you had a number, probably anything below 0.5 would really be no correlation. And then as you get, like I would say about 0.7, if you got to 0.7, that's when you start to see a pattern in something that was up to about a 0.7. And then the higher it gets from there, the stronger the pattern would get as far as the dots getting closer and closer together. So a question I might ask is I might give you these numbers. I wouldn't give you the graphs. I'd give you the numbers, and I would say, which one has the most reliable data? What would the answer be? Out of these three numbers, R equals 0.043, R equals negative 0.976, R equals 0.875. Which one's most reliable? The answer would be 2. It doesn't matter that it's positive or negative. That doesn't come into play at all. Reliable has to do with how high the number part is, because that means the dots would be closer together. And I might not give you the drawing, so don't rely on that. I might just give you the numbers. Or I might ask you to draw what the data might look like, and you might need to be able to recreate a graph where this is slanting down, but the dots are really close together. Again, these are slanting up, and the dots aren't quite as close together. So I would compare your two graphs to make sure these points were a little more spread out than these, and then for this one, there should just be no pattern at all. So those are the types of questions that I might ask. And basically, if you have all that stuff written down, you should be able to answer it. All right, so you guys have a ton of time. How are we so far ahead? That's everything. Maybe I just went through it a little bit faster. So here's what you're doing for the rest of the day. I'm gonna look at grades. If you know you're still missing a quiz, you can tell me to look it up and I'll look it up. But otherwise, I'm going to be having some people possibly make some stuff up. If everybody's good, or even if you're not good, you're still going to get started on the packet. You need to work on this packet. I'm not going to be helping with it for probably quite a while until I make sure everybody's made everything up they need. This is old stuff. You should be able to do something in this packet. First page is just two-step equations at the top. Then creating some simple equations down the bottom. Like the equations we first started where there's a total number on one side equals something times x plus something. Or maybe it's not in that format. Maybe I think most of it is on this page.
So is this extra credit?
No, there's not extra credit. There will be some extra credit possible. So if you do a good job today of doing this, I expect you to do some of it. Like, I mean, it's for a grade. So if you get a 0, it will hurt your grade. But if you do the amount I expect, and then more than that, then you will be able to get extra credit added into your grade, which some of you definitely need. Like I said, if you're within 3 points of the next letter grade, either direction, like you could drop 3 points and go below, or you could go up 3 points and go above, maybe even 4 points. This could change your grade. If you're right at like 75, 85, 65, probably not going to do a whole lot for you at those levels if you're right in the middle. But again, I wouldn't take that chance, because if it does drop you and all of a sudden you go down to the next letter grade, there's no making it up. If you choose to sit here and not do anything at all today, like you get a 0 on this, there's no, oh, Mr. Gill, how'd my grade drop? I had to say, well, because you turned in nothing for the last day. So make sure you do something. Like, even if you just do a few of the two-step equations to make sure you don't take a 0, make sure you do that. Now, if you're on a borderline, if your grade is close to dropping below or going over, you need to do as much as you can possibly do. The more you do, the more points you can possibly get.
Why is that?
But you need to get a lot of these done, because I believe you're on one of the borderlines. I think you're one of the people that's on them. Yes, sir.
Where the packet that you're talking
The one that says 1-2.
about?
I'm not going to grade, in all honesty, for whether you got the correct answer or not. I'm going to grade your steps. So for a two-step equation, you should be adding or subtracting. You're basically doing the opposite to get rid of the part that's just the numbers. And I'm talking about you're looking at the side where the variable is. So you should add or subtract. Then your last step would be to divide by whatever's in front of the variable. And that'll be your answer. Just again, right now, I'm not helping. You got to do your own thing because the more important piece is if I've got anybody still missing some kind of a quiz that they need to make up. Once I get done with that, then I'll start helping with the packet. But I got to make sure nobody's missing any grades, that maybe somebody that was absent last time we did this.